All right, welcome back, you guys. Your favorite pre-calculus 2 course, trigonometry. We're going to take a look at ellipses today. So this is basically an elongated circle. And let me kind of give you a little background as to where, or the definition of an ellipse. An ellipse is a collection of all points in a plane. Let me draw an ellipse here. So all these points, let me take one of these points right here. That is a fixed distance from the foci. So here's the foci, okay, and that is a constant. So let me call this focus 1. Let me call this focus 2. And so if you take the sum of their distances, so the distance from F focus 1 up to P plus this distance from the focus 2 to P, this is a fixed constant K. And by the way, this ends up being 2A, and I'll talk about what that value A is in just a minute. But that's so the fixed points. If you can imagine like this being kind of like a string and it's wrapping around, this is like a nail right there. And if you move that nail around, right, then that string is still the same length, right? If you move that around, it's still like, if it move the nail to there and it still wraps around. And that'll help you to kind of draw your ellipse, if that makes sense. But looks like an elongated circle. Let's go back here to our notes. So basically an elongated circle. Now, there's relationships here. If it's elongated horizontally, meaning the major axis, let me outline the major axis. The major axis goes between the vertices. So here's a vertex right there in green. Here's another vertex in green. The major axis is between those vertices. And the distance from one vertex to the center is A. And so the length of the major axis is 2A, A plus A, right? Because this side's also A. A plus A is 2A. So that's the length of the major axis. The minor axis, the distance to one of these, this is referred to as a covertex right here. Again, the green ones here is a vertex. Two vertices are two covertices. And see how this distance here is B? So that distance is B from the center up to a covertex is a distance B. And then finally, the distance from to one of these foci, this is my focus points in black right here. That distance is C from the center out to one of the foci, okay? And the relationship, you see the triangle in there? The relationship is B squared plus C squared equals, that actually ends up being A squared. So A actually is also the distance from a covertex down to a foci. And so a lot of the time we're solving for C here, so if I subtracted B squared from both sides and I square rooted, that would give me the C. So I want to remember the C, that's the relationship between A, B, and C. C is the square root of A squared minus B squared. The length of the minor axis is 2B as well, okay? And there's one other measurement that we'll find, and that's also the eccentricity. So it's how elongated it is. And so the formula for the eccentricity of an ellipse is the C value over the A value. If the eccentricity, if your C is actually 0, then it is a perfect circle. So the ellipse is a circle. But the larger the value of the eccentricity, the skinnier it becomes. The larger the eccentricity, the skinnier it becomes. Okay. Well, let's do an example here. Let's go ahead and graph x squared. Oh, and I'm sorry, I forgot to mention one other very important thing here. The A value is bigger than the B value, okay? Notice that when it's elongated, like in this case over here, when it's elongated or the major axis is horizontal, the A value is underneath the x squared. Whereas if it's elongated vertically, the major axis is vertical now. Major axis is vertical, it's elongated vertically. Then the A is underneath the y squared. Okay, so you want to keep in mind that the A value is always bigger than the B value. So let's go, with that being said, let's go over here. And notice we have x squared over 25 plus y squared over 9 equals 1. So I'm looking at this and I'm like, oh, 25 is bigger than the 9. So that's my A squared. And that 9 right there, that's my B squared. So I have x squared over A squared plus y squared over B squared. And that's 9 right there. Then the major axis is horizontal. Right? And we know A squared is 25, so A would be 5, square root, square root. We also know B squared is 9, so the B is 3. And the center, we're going to start out, this is just at 0, 0. We're just going to do all these with centered at 0, 0. So there's our center, 0, 0. The major axis is horizontal, so I'm going to go to the right 5. A is 5, right? So I got to go out 5. 1, 2, 3, 4, 5. I'm going to put a point. There's my vertex. There's one of my vertices. And I'm going to go to the left 5 as well. So I go left 5, 1, 2, 3, 4, 5. I put it. Okay, so here's my vertices. My vertices are at negative 5, 0, and 5, 0. That's based on the A value. Now, notice my B is 3. So my co-vertex, I'm going to go up 3 and down 3. Okay, so I could kind of draw this thing pretty decently at this point based on my vertices and my co-vertices. I'm going to add in co-vertices 0, 3, oops, and 0, negative 3, and add that line in. Okay. Now, let's go ahead and find our foci. Where are they at? So what's our C value? In other words, how far over do we go to find where our focus is, right? We're trying to find that value right there. Well, since C squared equals A squared minus B squared, C is the square root of A squared minus B squared. So C equals, remember our A is 5, so I got 25 minus a B is 3. So I got 25 minus 9, I got 16. So our C ends up being 4. So let's go to the right, 1, 2, 3, 4. And the foci, and then left 4. The foci are on that major axis. Okay, but it's out. Again, that's a C distance, right? So there's our foci at 4, 0, negative 4, 0. Let's go ahead and do the length of our major axis. That's 2A because it's A plus A. I'll do it in blue. A plus A is 2A. And we know our A is 5. So the length of the major axis is 10. The length of the minor axis, let's do that in green. Remember, this is B and this is B. So this minor axis length, right, that would be 2B. So we get 2 times our B value is 3, so it's 6. Length of the minor axis is 6. Our eccentricity, in other words, how elongated it is, the eccentricity equals C over A. So here our C is 4, our A is 5, so 4/5 or 0.8 is our eccentricity, 0.8. Focus, focus, there's our center, covertex, vertex, vertex. This next one, see how I got 36x squared plus 4y squared equals 144. Notice it is not equal to 1. I need it to be equal to 1, right? If I look back on these, notice they're equal to 1, right? So let's force that. Let's divide everything by 144. And so what we have is 144 divided by 36. Let's see, that'll give you 4. 144 divided by 4 give you 36. And now notice this is the bigger value right there, that 36. So that's actually my A squared. That one right there is my B squared. So I'm going to note that this is elongated vertically. In other words, the major axis is vertical, right? So it's vertical is the major axis. It's elongated that way. Okay, so that's kind of what I'm thinking before I do this. My center is still going to be 0, 0. I'm going to start right there. Notice my A squared is 36. So my A has got to be 6. Square root square. So I'm going to go up 6. I'm going to go down 6. 1, 2, 3, 4, 5, 6. Those are my vertices on the major axis. And then my B squared is 4. So square root, my B's got to be 2. So I'm going to go right 2, left 2. And those are my co-vertices. I'm going to add a line there. Negative 2, 0, 2, 0. My vertices were 0, 6, 0, negative 6. And I could kind of draw this, even though I haven't finished the problem here. I can kind of draw it. And by the way, if you punch this into Desmos, you can check your graph, your graphing calculator, Desmos.com. You can take a nice look at these. All right, let's do the foci now. Number 2. So we know that C equals the square root of A squared minus B squared. My A squared is 36. My B is 2. 2 squared is 4. So I got square root of 32. So that's like 5 point something. 5 point, let's see what that, 5.66. So we go up 1, 2, 3, 4, 5.66. There's one of my foci. 5.6. Oops, 1, 2, 3, 4. I went. Sorry, I did that. Not enough. 5.66, about right there. Down negative 5.66. So my foci are at 0, 4 root 2, 5.66, and 0, negative 4 root 2. The length of my major axis is 2a, so I got 2 times 6, so I got 12 is the length of my major axis. All right, so that would be in green. I'm sorry, in orange here. The length of that is 12 units. The minor axis length is 2b, so I got 2 times 2, so this would be 4. Let's go ahead and find the eccentricity. How elongated is this? C over A. So that would be 4 root 2 or 5.66 divided by 6. Let's see, that would be 0.94. 0.94. Okay. And again, if you want to check these, you throw these. Let's go ahead and throw this one in. Show you one of these graphs on Desmos. I go to desmos.com, click on that graphing calculator. We had x squared over 4 plus y squared divided by 36 equals 1. Oops. Equals 1. There we go. And you can see our ellipse that's elongated vertically. In other words, the major axis is vertical. All right, well, what if we move it off of the center? So now our center is at HK. So there's our centers now at HK. Well, if it's elongated horizontally, it'll be, instead of x squared over a squared plus y squared over b squared, it'll be x minus h squared plus y minus k squared over b squared equals 1. All right, so you're just moving at HK. Still, everything else the same. Major axis still 2a, minor axis 2b, eccentricity c over a, and so on. And if the major axis is vertical, it'd be the one on the right. So let's go ahead and do this one first. We've got x minus 2 squared over 16 plus y minus 1 squared over 4 equals 1. Now notice the 16 is bigger than that 4, so that's got to be my a squared. If the a squared is underneath the x squared, then I know that my major axis is horizontal. So this will be elongated horizontally. Right? Major axis is horizontal. Now notice x minus h squared, y minus k squared. So the h has got to be 2. That's my center. And my k's got to be 1. There's my center of this thing. 2, 1. There's the center. Now it's not centered at 0, 0 anymore. This one's centered at 2, 1. My a squared is 16, so I know my a is 4. So from there, I'm going to go right 1, 2, 3, 4. There's one of my vertices. I'm going to go left 1, 2, 3, 4 because I know my major axis is horizontal. I also know b squared is 4, so b is 2. So I'm going to go up 2 and down 2. And so my vertices are at 2 plus right 4, so 6, 1. And then my other vertex would be 2 minus 6, or negative 4, 1, if you want to count it on there where you're at. I'm sorry, negative 2, 1. Good grief. Negative 2, 1, 1. There we go. My co-vertices would then be at 2, 3, and 2, negative 1, if you want to write your co-vertices. Let's go ahead and solve for our foci. We know c is the square root of a squared minus b squared. A squared is the 16, b squared is the 4, so we got square root of 12 is our c. So that's like 3 point something. 3.46. So I'm going to go to the right 3. Let me do it in order. 1, 2, 3.46 right there. And go to the left 1, 2, 3.46 about right there. Those are my foci in orange. Can draw that there. So remember, this was at 2, 1. So I'm going 2 plus 3.46. So 2 plus 2 root 3, comma 1. And 2 minus 2 root 3, comma 1. Those are where my two foci are. The eccentricity be C over A. And so the eccentricity is square root of 7 over my A here is 4. So that ends up being 0.66. Major axis is 2A. So 2 times 4, so I got 8. It's my major axis length. My minor axis length 2B, so I'd have 2 times 2, so I got 4. Minor axis length is 4. Sorry about that. I had a student point out I screwed up this eccentricity right here. That should be square root of 12 or 2 root 3 over 4. So root 3 over 2 is 0.87. Sorry about that. All right, this next one, notice it's not in a standard form or not in that useful form at all. This is a very annoying 16x squared. I'm going to have to complete the square, so let me put the 64x next to it. Let me leave a space. I got the 9y squared. Let me put the minus 54y. You see that plus 1? I'm going to take that to the other side. So I'm going to subtract 1 on both sides. And I'm going to have to complete the square on both of these. So then what I'm going to do is I'm going to take a 16 out of this, the x squared and the 64. I'm going to take a 9 out of these. And now I'm thinking to myself, well, what number do I need right here such that it factors into a perfect square? And if you're not sure, it's always this b term over 2 squared. So 4 over 2 is 2. 2 squared is 4. So 4 is what I want to add in there to make that factor into a perfect square. Now, I didn't really add 4 to this side. I actually added 64. So make sure you account for that 16 in front. Now, before I go to the y, let's go ahead and factor this. X squared plus 4x plus 4 is x plus 2x plus 2. So there it is. We just factored that into a perfect square. Now, over here, what do we have? Well, we got this negative 6. The trick is to take that number divided by 2 and square it. That's the number I want. So negative 3 squared is 9. I want to add in a 9, but I really added in 81 to that side. Well, y squared minus 6y plus 9 is y minus 3, y minus 3. There's 2 of those. And so over here I got negative 1 plus 64 plus 81. Let's see, that gives you 144. Now I want this thing equal to 1, right? I want it equal to 1 to put it in the form. So what I'm going to do is divide everybody by 144. And so we'll have x plus 2 squared over 144 divided by 16. That gives you 9. Plus y minus 3 squared 144 divided by 9 gives me 16 equals 1. Now I'm in my form that I need to be in to go ahead and draw this ellipse. Remember, a is bigger than b, so this is my a right there. So that's my a squared. And this will be my b squared. So the major axis is vertical. So this will be elongated vertically. Okay, let me write so I'm thinking x minus h squared over b squared plus y minus k squared over a squared equals 1. So the center of this, the hk, the h will be negative 2, the k will be positive 3. Negative 2 comma 3. That's my center. So I'm going to go ahead and put that on my negative 2, 3. There's my center of this thing. My a squared is 16, so note, if a squared is 16, my a's got to be 4. If b squared is 9, then my b's got to be 3. And the major axis is vertical, so since a is 4, let me count up 4. 1, 2, 3, 4. Put one of my vertices. 1, 2, 3, 4. Put my other vertex down there. And then let me put on the co-vertex. B is 3, so let me go right 1, 2, 3. Left 1, 2, 3. And I could kind of draw it now. I know I don't have my foci on here yet, but oops, I kind of struggle to draw these things. But yeah, so my vertices would be, since this center was at negative 2, 3, I went up 4 and down 4, right? So the 3 changes, the y value changes. Negative 2 stays the same, but 3 plus 4, that'd be 7. And then 3 minus 4 would be negative 1. So there would be my vertices. My co-vertices would be, let's see, the x value now changes. So negative 2 minus 3. So I got negative 5, 3, and then negative 2 plus 3. I got 1, 3. That would be my co-vertices. Right there and on the left-hand side there. My foci, let's go ahead and find our foci. Well, our c is the square root of a squared minus b squared. So my c here, let's see, my a squared is 16. I have 4 squared minus 3 squared, 9. So here's my square root of 7. And so my foci, square root of 7 is like 4 point something. I'm sorry, 2 point something, 2.7 something. So I'm going up 1, 2 point a little bit, down 2 a little bit. If I could kind of draw the foci here. But I'm going to do it in exact form. So I'm going negative 2, 3, up or down root 7. So there's both points. Negative 2 comma 3 plus root 7. Negative 2, 3 minus root 7. That accounts for both of those. Major axis, here's my major axis in red, right? Major axis is the length 2a. So I got 2 times 4, so I got 8. My minor axis would be 2b, so I got 2 times my b is 3, so I got 6 on that one. My eccentricity is c over a, so that'd be the square root of 7 over, my a is 4, square root of 7 over 4, 0.66. So this next one here, this would be a good one, good time to pause the video and make this a you try it problem where you complete the square first. Hopefully you noticed first on this one, you just got an x squared. There's no bx term, so I'm going to just leave a space there. Then I'm going to write my 16y squared minus 160y, and then a plus 384. I'm going to take that, I'm going to subtract 384 from both sides. Remember, we want this thing, I want a perfect square plus another perfect square equals 1, right? That's what I'm trying to get to. Well, I already got the perfect square from that one. This one I'm going to have to take a 16 out. And I'm going to have to complete this square. So I take negative 10 over 2 is negative 5. Negative 5 squares 25. So 25 is what I want to add in here. But I really added 16 times 25, which is 400. Okay. So now we have x squared. That's a perfect square. That's nice. This one now will factor into y minus 5, y minus 5. And we got negative 384 plus 400, which is what, 16? Now I want this equal to 1, so let me divide everybody by 16. So I get x squared over 16 plus y minus 5 squared over 1 equals 1. Perfect. See how I'm in the form. Whoops, and before I write my form here, notice that's bigger. 16 is bigger than that 1 right there. So that's my a squared. That's my b squared. So I'm going to have the form x minus h squared over a squared plus y minus k squared over b squared equals 1, which means my major axis, if it's the a is under the x squared, the a squared is under the x squared, then the major axis will be horizontal. So it'll be elongated horizontally, right? Now, let's identify our center, h. See how I have x minus h? I just have an x, so it's like x minus 0. So h is 0. Y minus k, there's my k5. So 0, 5 is my center of this thing. 0, 5 is my center. 5, 0, 5. Oops. Just put a C for my center here. And then my a squared is 16. So if a squared is 16, then my a is 4. My b squared is 1, so my b is 1. Remember, the major axis is horizontal, so I'm going to go right 4. And I'm going to go left 4. 1, 2, 3, 4. Those are my vertices. So 0, right 4 would be 4, 5. And get this thing to right. There we go. 4, 5. And negative 4, 5. My covertices would be up 1, down 1. So my covertices would be 0, 6. Let me write my covertices. 0, 6 and 0, 4 would be my covertices on this. My foci, number 2. Well, C is the square root of a squared minus b squared. My a was 4, so 4 squared. My b is 1, so I got square root of 15 would be my C. Well, square root of 15 is like 3 point something. 1, 2, 3 point something. 3 point something. You can see how this thing's pretty skinny, right? The foci is way out there close to the vertices. So the foci would be at right square root of 15, comma 5, negative square root of 15, comma 5, plus minus root 15, comma 5. Length of the major axis, 2a, so we got 8. Minor axis is 2 times b, so we got 2. Our eccentricity is c over a, so we got square root of 15 over 4, 0.97, so it's pretty skinny there, 0.97. Our last 3 problems are a different look. Now we're going to be given some information about the ellipse. So in this case, find the equation of ellipse with foci 0, 1. The other foci is 0, negative 1. So if that's our foci, we know the center's right in the middle. So the center's got to be at 0, 0, right? And notice it also gives us the vertices. 0, 4. There's a vertex. 0, negative 4, right? So there's our vertices. So we have, what information do we have? Well, the center to a vertex, that's our a value. From the center to a foci, there's our c values. Our c value is 1, Our A value, you can see, is 4, right? And we know our center HK is 0, 0. And we also know the major axis has got to be vertical as it goes through the center to the two vertices. So the major axis is vertical. Again, we know A is 4, we know C is 4, C is 1. So I'm thinking to myself, well, if the major axis is vertical, that means x minus h squared is over b squared. Y minus k squared, and then you got the a squared under there. We know hk is 0, 0. We know a is 4. Let's go ahead and plug the a in right here. A is 4, so that's a 4 squared right there. I don't know my b yet, like where that covertex is. So I'm going to go to the side. After I've notated the information given, the equation I'm going to use, I know c is equal to the square root of a squared minus b squared, right? My c is 1. My a is 4. We could solve this. I would go ahead and square both sides. So you got 1 squared, which is 1, equals, that'll undo the square, so I got 4 squared, 16 minus b squared. Let me add b squared to both sides. And subtract 1. There's my b. B is the square root of 15. So b squared is just 15. Oops. So I got x squared over 15 plus y squared over 4 squared, 16, equals 1. There's the equation. And knowing that b is the square root of 15, so that's like 4 points. I'm sorry, 3 point something. I'm going to go right 1, 2, 3 point something. I'm going to go left 1, 2, 3 point something. That kind of helped me draw this thing. So pretty rounded, this one, because my eccentricity is closer to 0. So it's a little more circular rather than so skinny. Now this next one, notice they give, find the equation of ellipse centered at the origin. Let's go ahead and put the center right there. There's our HK. So HK is 0, 0. There's our center. And it has an eccentricity of 3 over 5. Well, we know eccentricity is C over A. So that's going to be very helpful. Our C is 3. Our A is 5. I'm just going to notate some information. Our center is 0, 0. And then it gives one of our vertices here is negative 5, 0. So I'm going to count 1, 2, 3, 4, 5. So that means the other one, since it's centered at 0, 0, would have to be 1, 2, 3, 4, 5, comma 0 would be the other one, right? And so then my major axis has got to be horizontal because it goes through my, oops, it hits my vertices and goes through my center. And so I know, since the major axis is horizontal, it'll be x minus h squared over a squared. And I know HK is 0. I know my A is 5. There's my K. K is 0 also. I don't know my B yet. Let me leave that blank. So let's go to the side. And I know C is the square root of A squared minus B squared. My C here is 3 from the eccentricity. My A is 5. If I square both sides, I'll have 3 squared is 9. It'll undo that. 25 minus b squared. So b squared plus 9 equals 25. Subtract 9 on both sides and I get 16. So b is 4. So 4 is being squared. So I have x squared over 25 plus y squared over 16 equals 1. So my B is 4, 1, 2, 3, 4. 1, 2, 3, 4, and I could kind of draw that thing if I wanted to. All right, and I could even put on my C is 3, 1, 2, 3, 2, 3. There's my foci as well. Vertices, vertices, co-vertices up there. All right, one more. Find the equation of an ellipse with a foci 1, 2. 1, 2, and negative 3, 1, 2, 3, comma 2. Well, if you notice, here's my foci. So the center's got to be smack dab between them right there. So the center is the midpoint of those 2 points. So, you know, you can either use the midpoint formula or just count it. It's pretty easy to see that that's got to end up being negative 1, 2 right there would end up being your center. But if you want to use the midpoint formula, it's x1 plus x2 over 2, y1 plus y2 over 2. So x1 plus x2, 1 plus negative 3 is a negative 2 over 2, and then y1 plus y2 over 2. So it looks like I got negative 1, 2. There's our center, just to verify it algebraically. All right, we can see it visually as well. So we've got our HK. We know the major axis, since it's going through these foci right here, this major axis has got to be horizontal, right? And so I'm thinking to myself, x minus h squared over a squared plus y minus k squared over b squared equals 1, since my major axis is horizontal. I have HK. I do have more information given. I did not finish this. I do have another vertex at negative 4, 2. So let's go ahead and put that vertex on right there, which means the other one would be right there. There's my vertex, negative 4, 2. So what's the A distance from the center out to a vertex? 1, 2, 3. It looks like A has to be 3. Right? So my A is 3. Now I do not know my C yet. I'm sorry, I do know my C. Let me put my C on. See how my C is 2 right there, distance from the center to a foci. So my C is 2. So let's go ahead and solve for my B. So I got 2 equals 3 squared minus B squared. Square both sides. So B squared equals 5. So I got root 5. I got root 5 being squared. So we got, finally, let's go ahead and write this. X minus my H, the center. Oops, come on, don't be doing that. No. X minus H over A squared. Y minus the K squared over B being squared equals 1. So I got X plus 1 squared over 9 plus Y minus 2 squared over 5 equals 1. And that there's the equation of that ellipse. And we could also draw, let's go ahead and draw this as well before I finish. Excuse me. If B is the square root of 5, so that's 2 point something up from the center and down 2 point something. So you kind of draw this thing through those co-vertices. Okay. Thanks so much for watching. Take notes. See you guys next time.